Hello everyone. In the previous section, we have discussed about the types of numbers, which is the basic concept of number system. We talked about natural numbers, whole numbers, integers, rational numbers, and we know how to represent them on number line. So on the number line, are we still left with some numbers which we can represent on number line? Yes, of course. We are left with irrational numbers. These numbers can also be represented on number line. So you should know what are irrational numbers. Any number which cannot be written in the form p upon q, where p and q are integers and q is not equal to 0, are called irrational numbers. So the numbers which we cannot write in p upon q form are called irrational numbers, and they are denoted by q bar. Rational numbers are denoted by capital Q, whereas irrational numbers are denoted by capital Q bar. This is the symbol of bar. So examples of irrational numbers are root 2. This is the symbol of square root. So root 2, root 3, root 5, 0 0.10, 110, 110, 4 times 10, and so on, along with pi. Pi is also an example of irrational number. So these all are the examples of irrational numbers. Children, you know that between two given rational numbers, there lies infinite rational numbers. So the same way, there are infinitely many irrational numbers too. Next topic is real numbers. What are real numbers? The collection of all rational numbers and irrational numbers together make up the collection of real numbers, and they are denoted by capital R. A real number is either rational or irrational. So real number actually consists of natural numbers, whole numbers, integers, rational and irrational numbers. So we conclude that every real number is represented by a unique point on the number line. It means we can represent any real number on the number line, and its opposite, every point on the number line represents a unique real number. For example, 2. 2 is a real number, so we can represent it on the number line. So it can be better understand. We can better understand it with the help of this diagram. So this diagram consists of real number. So the main thing is real number, and real number consists of natural numbers, whole numbers, integers, rational numbers, as well as irrational numbers. So now come to representation of irrational numbers on number line. Let us see how we can represent irrational numbers on number line. So we'll take an example. Let us take an example 3. Locate under root 2 on the number line. So let us see how we can locate it on the number line. For this, what you have to do is, you have to draw one number line. See, you can draw one number line. Take here O. Then you have to take 1 unit. Scale is 1 unit, and I have taken 1 unit is equal to 3 centimeter. Since 1 unit, if we take 1 unit 1 centimeter, it is too small to make. So I am taking 1 unit is equal to 3 centimeter, and this is A. So this is 1 unit. Now what you have to do is, you have to make 90-degree angle on point A and join it, not too much. Now you have to take again, the base is 1 unit, and we have to take perpendicular also 1 unit. 1 unit means 3 centimeters. So this point is B now. This is also 1 unit. So we are using Pythagoras theorem for making root 2, for locating root 2 on the number line, by taking base as 1 unit and perpendicular again as 1 unit. Now you have to take, what you have to do is, you have to join OB. Now open your compass from O to B. So it means radius should be OB, and drag this point on the number line. So this point is P. So O to P represent root 2. So OP represents root 2. This is how we can represent root 2 on the number line. Now these are the steps. See, you can see from here. Step 1 is on the number line. So this is the number line. In the figure we have points O and A. So this is point O and this is point A, representing numbers 0. So this represents 0 and this represents 1 respectively. So take OA is equal to 1 unit and the scale is 1 unit is equal to 3 centimeter. Now step 2 is draw AB is equal to 1 unit, taking perpendicular to line at A. So first of all draw perpendicular at A and then take AB 1 unit, join OB. So we have joined OB, we find, so using Pythagoras, hypotenuse is equal to perpendicular square plus base square under root. So since you can see OA is 1 unit and AB is 1 unit, so 1 square plus 1 square makes 1 plus 1 root 2. So OB represents root 2. And now taking O as center and radius, taking O as center and radius OB, root 2 units, draw an arc which intersect the number line at point P. So taking this radius, you just drag this radius here on the number line, you get point P. So we observe that OB is equal to OP root 2. So point P on the number line represents the irrational number root 2. Next is locate. Next example is locate root 3 on the number line. So we have to proceed in the same way. For making root 3, again we have to use Pythagoras theorem. Here we are using base as root 2 square and perpendicular again as 1 square. So 2 plus 1 makes root 3. So base is root 2 units, perpendicular is 1 unit. So you can see for making root 3, we have to make root 2 first. So this is already root 2 is there. So what you have to do is for making root 3, you just keep your protector at OB and draw a 90-degree angle just like this. Again you have to take 1 unit perpendicular. Base is root 2 and we have to take perpendicular now 1 unit. See this, and name this point D. Again perpendicular is 1 unit, join OD. And again taking O as center and OD as radius, just drag this distance on the number line. So this is Q. So from O to Q represents root 3. So OQ represents root 3. So now you're clear this OQ. First of all, what you have to do at B, draw 90-degree angle, take perpendicular 1 unit, cut an arc, join OD and drag the distance from taking O as center, drag this distance on the number line, you get OQ as root 3. This is how we can locate root 3 on the number line. Now come to exercise 1.2. State whether the following statements are true or false. Justify your answer. Every irrational number is a real number. So answer is true. Question is, every irrational number is a real number. Yes, this is true, since collection of real number is made up of rational and irrational number. Because real number consists of rational and irrational, so every irrational number is a real number. Next, every point on the number line is of the form root m, where m is a natural number. Answer is false. because no negative numbers can be the square root of any natural number. For example, minus 1. Minus 1 is an integer. It is a real number, but its square root is not possible. So we cannot find the square root. We cannot represent minus 1 root on the number line. So this statement is false. Then comes third part. Every real number is an irrational number. This is again false statement because example is 3 is a real number. We know 3 is a real number, but it is not irrational. So because real numbers consist of natural, whole numbers, integers, rational and irrational number, so all real numbers are not irrational. Some real numbers are rational also. So question number 2 is, are the square root of all positive integers irrational? If not, give an example of the square root of number that is a rational number. So its answer is, square root of all positive integers are not irrational. You can take an example of root 4. Root 2 is irrational. Square root of 2 is irrational. But if we take an example, square root of 4. We know square root of 4 is 2 and which is a rational number. Square root of 9 which is equal to 3. Again it is a rational number. Square root of 25 which is equal to 5. Again it is a rational number. So square root of all positive integers are not irrational. Then comes question number 3. Show how root 5 can be represented on the number line. So you can try this sum yourself, but I will give you a hint. Before making it, you have to again use a Pythagoras theorem. OB you have to take, OB is the hypotenuse which will come root 5. You can take base as 2 units. Again, the scale should be 1 unit is equal to 3 centimeter, but now you have to take base 2 units. And perpendicular you have to again take 1 unit. With the help of that you can easily make root 5. So OB you will get root 5 on the number line. So you can try this construction yourself. And question number 4 is, this is a classroom activity. So this is a spiral. So this will be done later on. So thank you. This completes your exercise 1.2.